benevolent elephants. 11 benevolent elephants.
That would look cool. 11 just like really deep in thought elephants. That'd be kind of cool.
But they're benevolent. They're not pensive. They're just calm.
Words.
Words. We don't have to talk about words today.
We're going to use words to talk about things, but I don't want to talk about words.
I mean, don't we always use words to talk about things, or is that... No.
You can't get away from it. I guess you can't get away from it. Be comfortable in the fact that we're part of a species that's evolved to use language.
How you doing today, Benjamin?
Doing good. Been a busy week. It's been an interesting week, but I'm good. How about you, Kovi? How you doing?
Busy. Nice. I feel like we've had a lot of fantastic guests over the past few episodes, so it's been wonderful, but it's nice to just have you and me just chit-chatting.
Just taking a break. Just taking a pause.
Yes. It's still wild to me that we're on season 7. I kind of can't believe it. I feel like most podcasts... They just kind of, they tend to like appear, they do a season, they do like 10 or so episodes, and they just kind of drift off into the void.
Anyway.
Yes. What are we chatting today about, Benjamin?
Today we had the fun idea with talking about things in space that are named after people. During our last episode with our favorite ass, Daniel Orovma, he talked about, we covered briefly the comet passing through our solar system, something 3 Atlas or whatever.
Yep, 3i Atlas.
3i Atlas, there it is. And that's a really easy name to remember that just rolls off the tongue. And we're going to start thinking, what about names of, spacecraft and satellites or observatories or any other, anything else that's named after, scientists or people, and why?
And yeah, that's right. And we covered a few different ones during that episode, like in passing, but we didn't really get a chance to dive deep into them.
So we put together a list of a whole bunch of them, and I thought we could just go over them and maybe even talk about a couple of things that these items are famous for. We can start with the most famous one. Jump right in. The Hubble Space Telescope.
Hubble Space Telescope, yes.
Do you know who it was named after?
I think it was probably named after Big Bird.
Close. It was named after Kermit. Kermit's real name was Edwin Hubble, and he was often referred to as the father of observational cosmology. And go on.
I feel like people throw around terms like that, like the father of this, and like, but putting aside like why that's
Uncle
like
twice removed of observational cosmology.
But I think it's also like, it has whatever like social implications, calling someone the father or something. But it's also, in this case, I think kind of an understatement when you think about the fact that like until Hubble's work, we didn't know that other galaxies existed.
Wow.
Right? There were like huge like I want to say like a battle royale, like that, like astronomers would get together, like scientists would get together, and they would have these debates over interpretations and these ideas that what we now know today as galaxies were just like these, nebulous clouds of gas and dust floating around the Milky Way, which at the time was the whole universe. Like it's wild to me that thanks to this man's work, we actually know that there are other galaxies out there. Sorry, I had to
No,
fanboy a little.
that's fantastic. That's exactly what we want to do. He's done all sorts of things, and he helped set the stage for the Big Bang Theory expansion of the universe.
Great
And
TV show.
yeah, and a good, and he made that TV show. I wonder how many times he was referenced on that TV show, because that was a very clever show. They did everything like scientifically right, or they tried to.
There were times that I would look at the whiteboards in the background while I was
Right.
watching with my partner and try to like figure out what they were doing and whether it was actually connected to what they were saying.
Ah, it's great. All right, next one. Let's go for a more recent one.
Yes.
The JWST, the James Webb Space Telescope,
Yes.
named after James Webb, but I believe there's also a bit of a controversy over the naming of this one.
There is a bit. I I think that there's a bit of controversy in terms of what James Webb's attitudes, either actively or passively, might have been towards LGBTQ plus people during that time.
Got it.
And I think that depending on what opinion you have, it's somewhere along the spectrum of did nothing to prevent or was unable to do anything to prevent discrimination against LGBTQ people, to the other end of the spectrum of himself being homophobic.
Mm-hmm.
I personally don't know where on that spectrum it lies. I think either way, was certainly room for improvement.
Sure.
And I certainly understand that some folks were not thrilled, and so some people, definitely there were whole campaigns to rename the telescope.
Yeah, I remember that.
I think for the most part, people settle on just not using the full name
Yeah.
and just call it,
JWST.
yeah,
But James Webb still had a positive impact. He kind of led NASA during the juiciest part of NASA's history, when they first Mercury astronauts, the Gemini astronauts, and the beginning of the Apollo missions. He was the guy in charge of NASA. So pretty cool. Not a scientist. And as we go down the list, we're going to find out there's a few people on this list who are not scientists. Excuse me. But pretty cool.
there are definitely a lot of people who found themselves in a position to contribute to science. I mean, someone like Hubble was astronomer and a keen scientist, and made direct scientific contributions, kind of like they've got the stamp of approval of a PhD, like they're doing the thing, they're the scientist. But some of these people were more like yourself. They were just big space nerds, and they ended up in a position to contribute despite not having the same sort of formal training. So yeah, definitely someone like Webb, who despite the things we mentioned, he was someone in the military, someone who served at various government roles, constantly looking to make contributions, and a lot of those contributions towards the later part of his life were to NASA, as you mentioned.
So there's a chance for a Salis telescope. Okay. Okay. All right.
Could be.
Could be. All right. Next one. This is a fun one. The Chandra X-ray Observatory.
Ooh, yes.
Do you know who that one's named after? Can you pronounce
Okay,
the
so
full name of this Nobel Prize winning astrophysicist?
so the Chandra telescope, I think, is named after Chandrasekhar. Is that correct?
That's his last name.
Um, okay, so I want to point out, as far as I know, Chandra is the Hindi word, or I'm not sure if it's the Hindi word for moon or if it's the Hindi word for the god of the moon. I might be mistaken. But I have noticed a lot of people with the names Chandra or Chandrasekhar who work in astronomy, which I think is pretty cool. That's just as an aside.
It's
But yeah, I think I think if we're talking about the same person, so Chandrasekhar, whose first name was um, Subramanian,
got it.
is that I hope I'm
Wow.
pronouncing that correctly.
You pronounce it
Sub-
100% perfectly well, like an absolute native. Well done.
um, so Chandrasekhar was like a brilliant theoretical physicist. I mean, we've spoken a lot in the past about supernovae and white dwarfs. Um, the mass limit at which a white dwarf will no longer be able to be stable and will then explode as a Type 1a supernova is named after Chandrasekhar. That Chandrasekhar mass limit of
Hmm.
about 1.5 or 1.4 times the mass of our sun. Um, so yeah, brilliant, brilliant human beings. The Chandra telescope is an X-ray telescope, has done an incredible job kind of opening our eyes into the X-ray world at high resolution. Um, it does unfortunately seem like it's losing funding,
Yep.
unfortunately,
Right.
which is very
But
sad.
it's been running since 1999, and that is an incredible, incredible lifespan for something to be working in space
Yeah. Oh yeah,
and still
absolutely.
be on the cutting edge 25, 6 years
Oh yeah.
later. It's
Same
incredible.
goes for Hubble.
Yeah, same as the Hubble. Next one, the
Yes.
Compton, the Compton Gamma Ray Observatory. Do you know who that is named after?
I mean, I know that there was a Compton who discovered scattering. Um, I know that there was like a
Yep.
few different quantum effects, I guess similar to Chandrasekhar, that were named after. I think they were discovered by Arthur Compton. I don't know if that's the same
Arthur Hawley
Compton.
Compton discovered the Compton effect, the scattering of X rays by electrons, proving that light has particle like properties. Well done, you.
I didn't thank you. I didn't know that there was a Compton gamma ray telescope. I don't work a lot with gamma rays.
Well, you should, because there's a really good one out there. Well,
Yeah,
there was. It's gone now.
it's gone. No more.
But there's
um,
another gamma ray telescope that is working right now. It
hmm.
is the Fermi Gamma Ray Space Telescope, named after
Yes, Enrico Fermi.
not a lot of Fermis out there, a lot of Smiths, not a lot of Fermis. Enrico Fermi. What do you like about the
Yeah.
Fermi Gamma Ray Space Telescope?
Um, what do I like?
Like
I think
how shiny it is.
I think what's so so there are two things that are kind of uh, in balance when I think about like high energy space telescopes. It's the
Mhm.
fact that they're like super cool because they are in space, and um, we cannot actually study these wavelengths from here on Earth because our atmosphere blocks radiation at those wavelengths, which is a good thing because we don't want a ton of like gamma radiation just like plowing down on us from space. But then that's kind of balanced with the fact that when they are in space, not because they're in space, but just by nature of like what these how these photons work, they're so high energy, and they're actually kind of difficult to build technology that captures them. Um, and so it's like a really cool piece of technology to understand how these high energy telescopes work. So I just think the fact that they work, the fact that we can capture them at all, to me is the coolest part.
That's pretty cool. They discovered the millisecond pulsars with this thing.
Oh, did
Very
they?
cool. Yes, it did. Well, according to the seriously really long, deep wiki study I did. But yes, I did. Next
I
one.
I would have I
Oh,
would
go
have
on. Go
thought
on.
that. Sorry, I always associate pulsars with radio astronomy, but that's I'm biased. So I would have assumed that millisecond pulsars as well would have been discovered um, with radio telescopes, but I guess it could have been confirmed, maybe with gamma rays.
Oh, maybe to be further reading. I have made a note.
For
Actually,
further reading, and for folks who are listening, if you are a millisecond pulsar expert, please feel free to write into us or comment on wherever you're seeing this episode, telling
absolutely.
us that we're dum-dums.
We would love to talk about millisecond pulsars for longer than a millisecond.
Yes.
The Planck satellite.
Ah, yes, named after Max Planck.
Yes.
It's funny actually, like as we go through this list, to realize how many of them, how few of them are named after astronomers, and how many of them, when they're named after scientists, are named after like theoretical physicists who worked on like quantum related things.
That's
I
amazing,
hadn't thought
actually.
about that
I
before.
did notice that. There's a lot of
Yes.
them named after the physicists, and not so much the observational people. It's actually kind of funny. And one of them, coming up on the list, it was named after one of the guys who helped bring the material up to build the observatory, and then eventually he
Ooh.
stayed on and became the observing astronomer.
Oh yes, the old. Oh, I'm here anyway.
I'm here. Here's not what I brought up here. I'm going to stay. And next thing you know, making discoveries like crazy. We'll get
Okay,
there. Yeah,
we'll get there.
but Planck satellite was named after the German theoretical physicist who worked heavily in quantum theory. And notable achievements are the high precision cosmic microwave background map, which
Yes,
helped create the most detailed map of the cosmic universe.
it's yeah. It's so the Planck telescope maps. Like I use them when I teach undergraduate students about Big Bang theory and like understanding how this map that shows basically like a mostly uniform cold temperature at this wall. Well, basically, the CMB, the cosmic microwave background radiation, is this, so to speak, a wall at which point everything after it was stuff that we could see, right? So as as most of our listeners know, when you use a telescope, you're not just looking out into space at greater distances, but the further you look out, the further back in time you're looking, because the speed of light, yada yada yada. And so you can only get to a certain point, no matter which direction you look in. At a certain point, you hit this wall of the CMB, and that's because you're hitting a time that's about 300,000 years after the Big Bang.
First light.
And so between the Big Bang and 300,000 years, more or less, there was just so much happening. It was basically like a really thick soup of electrons that there were, anytime a photon would get emitted, anytime a light particle would start traveling, there would be just so many hot electrons for it to interact with in its neighborhood that it would just like ping pong and bounce off them and never actually get a chance to escape. So that wall of the CMB is the point at which enough of these hot particles combined into larger things that there was a decrease in the temperature, a decrease in the density of these electrons, and so photons were able to escape. And so this telescope shows us this, right? We are able to see with the Planck maps this background radiation that's left over from the first particles leaving.
That's just
It's wild.
Ugh. Ah.
Yeah.
Next is the Herschel Space Observatory.
Okay, this could be a trick question. It could be named after either the father or the son or both of them.
Oh, really?
I don't know, actually.
From what I read, it was named after William Herschel.
Okay, so the father was, okay. So there was the father was William Herschel, and then the son was John Herschel, I think.
Okay.
there's like a father and son astronomer duo. They were serious astronomers.
One
Sorry,
of
not
them
to throw
discovered
shade on
Uranus.
theoretical fit. Yes,
Suppose it's named after the one who discovered Uranus,
naturally.
and also discovered some other moons of Saturn and moons of Uranus as well, and helped discover some of the structure of our galaxy. So, which one was that? Was that William or John, or was that the combo?
William, I think William was the one who discovered Uranus.
Sweet.
Um,
Nice.
I'm remembering now that William also had a sister Caroline who worked with him a lot and naturally gets a lot less credit. And I think that some of the discoveries that you mentioned may have actually been Caroline's
Hers.
work.
Yeah.
Yeah,
Lame. Well, props to you, Caroline.
seriously, yeah, and it is continues to be upsetting to discover how many of these wonderful astronomers were female and didn't get recognition for that work because of that fact. Disappointing, but yeah, I think that astronomy is in a much better place these days.
I totally agree.
Yeah.
Next one. This is a fun one, a favorite one of mine, actually. The Kepler Space Telescope. It's sad it's no longer running, but I loved it. Named after Tycho's
Johannes.
buddy.
Tycho's bruh.
Tycho's bra. Actually, Tycho's is, what's the word the kids use? Oppo or op? Because they were adversarial astronomers.
No, because Tycho's surname is Brahe, so I was trying to make
Oh,
a bad
and
joke.
that's even better.
I'm sorry.
Wow.
When you have to explain a bad joke, everybody knows it gets better. That's how this works.
I have teenagers, so the word bra and oppo or op or whatever and 6 7 or whatever is going on. It's constantly at the forefront of, of the vernacular here at home, and so
Kids these days.
don't speak English. Anyway, Kepler Space Telescope.
Yes.
Named after
Johannes Kepler.
Johannes Kepler.
Yes. Brilliant dude. Basically took the data that Tycho Brahe had gathered and used that to derive Kepler's laws, which are still like fundamental and useful for understanding how orbital dynamics work.
3 laws.
Yes.
Even I know them.
Let's see.
Oh, okay. 3 laws of Kepler's laws of planetary motion. 1, an object orbits a star in an ellipse, and a star orbits an ellipse with its star at one focal point. 2, it sweeps out equal areas in equal time. And 3, something to do with like the cube of this is equal to the square of that. Some sort of something to do with the. I think the traveling. It's I forget. So, but the cube of something and the square of something. There's a math.
No, yeah.
I'm close.
It's 100%. Yeah. It's
I get
so
I get 70%. I give myself a C.
Honestly, I reckon that's better than most astronomers could do off the top of their heads. I think the third one is the so if you take the orbital period and square it,
Okay.
then that value will be proportional to the cube, as you said, of the semi-major axis, which is like the distance separating the two bodies.
Okay. So there you have it.
Yeah. So if it's an elliptical orbit, then it's basically like the long length of the ellipse, and it is an elliptical orbit, as we know. But yeah, there are various like approximations that people do, especially if you work with close binaries that tend to be almost circular. But that's a story for another day.
That's another day. That's a good one. I love that one. All right, here's a good one. All right. European Space Agency named this satellite the High Precision Parallax Collecting Satellite. The High Precision Parallax Collecting Satellite, which has been abbreviated down to, you
Hips.
know this one, Hipparchus.
Oh, Hipparchus. Yes. Hipparchus was, I want to say, an ancient Greek uh,
Astronomer.
astronomer
Yep.
slash philosopher slash mathematician slash
Mm-hmm.
what was geometry. Yeah, I forgot about the Hipparchus satellite.
Yeah.
Super useful catalog of stars that I remember during undergrad I used that catalog to create HR diagrams, which I think we've discussed in a previous
I think
episode.
we
But these
did.
diagrams that show us, you know, like the relationship between the temperature and the brightness of stars and stuff like that. So yeah, I had forgotten about this one.
Right. Correct. All right. We have one that's not named after a real person at all, but rather after a mythological person, Gaia,
The Gaia
which is
satellite.
still running. Yes. Up and
Too
running.
soon, man.
Huh?
It's sad. Yeah, Gaia's stopped taking data now. It's
Oh, it
I
did?
think I'm pretty sure it has stopped taking data
Oh, man.
a couple of months back. It's real sad. So as I mentioned just a moment ago, like the Hipparchus catalog, super useful. I don't remember exactly how many thousands of stars were observed in those catalogs, but with Gaia,
118,000.
118,000. Okay, yeah. So there's 100 billion. Nice. There's like a few 100 billion stars in the Milky Way.
Right.
So getting 118,000 is, you know, it's not a representative. It's not, well, that's not fair. It is a representative sample. It's useful, and scientifically, it was great. But you're barely scratching the surface.
Mm-hmm.
And with Gaia, not only is the number of stars observed by Gaia orders of magnitude greater, so Gaia observed something like 2 billion
1.8.
stars in its lifetime. What's that?
1.8.
1.8. I
Read my
am.
notes. Read my
I
notes.
do. I do astronomy, but my training is as a physicist, so you know that 3 is approximately equal to 10, right? This is
It's right. It's closer than one. I mean, hello.
um, order magnitudes. But yeah, so nearly 2 billion stars observed with Gaia, and the not only is it orders of magnitude greater stars than what we got from the Hipparchus catalog, but we also have multiple epochs, multiple data releases that have come from Gaia. So I think the one that's about to be released is data release 4. And with each of these, what we're seeing is basically improved data quality in general, because we're learning things about how we process the data and fixing things up on the telescope and learning more in general. But also, we are able to compare from observation to observation. Gaia is also fantastic in that it gives us, or gave us, 6 degrees. So you would have 3 spatial degrees and 3 velocity degrees. So not only could you say, what like the XYZ coordinates were of a particular star, but you could also say what the XYZ velocities are, right? So in each of those
Wow.
directions, how fast is it moving? And so we can track the proper motion of stars through the Milky Way galaxy using Gaia. Absolutely phenomenal. Phenomenal. And it is, well, we still have more data to come, even though the telescope has stopped taking new data. But I would say that everything that we have gotten from Gaia, it is an aptly named telescope if it's named after Mother Earth or the Earth god in mythology, because it is so useful to all of Earth, all of humanity.
That's fantastic.
I
Love
love it.
that. That's the trail.
I can rant about Gaia all day.
Oh, noting Gaia for another episode. All right, here's one. It's named after two people, and it went to Saturn.
Two people went to Saturn.
Yep.
Huygens?
Cassini-Huygens.
Yes, Cassini-Huygens. Okay, I forgot. Yes.
Right.
Uh, both astronomers.
What I did not know, I knew they were astronomers from a long time ago. I didn't know they were born around the same time in the 1620s. I did not know that. They were alive
And
at the
but
same time. We're doing the same similar work at the same time.
and
I should,
Huygens was Dutch, right?
Huygens was Dutch. Cassini was Italian French.
Okay. Yes,
And
very cool.
these guys discovered so much stuff about Saturn independently of each other. The moons, the rings, or paid a lot of attention to the rings anyway. But fantastic that these two names got sent to that worked at the same thing at the same time hundreds of years ago. Got sent to Saturn together. It's fantastic.
It's amazing. And there's like this huge gap actually between the discovery of Saturn's rings and the understanding of what they were. And so people like Huygens, who devoted much of their lives to understanding that it's a complex kind of, it's not just like a solid object rotating, and there were various other weird interpretations of what the ring system might have been, but like to understand how it's comprised of a bunch of smaller bits of rock and ice and stuff.
I wonder what
Super
people thought
important
it used to be. That's interesting.
Well, there is one theory that may not be super family friendly, but I'll I'll try to tiptoe around it. Basically, there was a theory that the rings of Saturn were I don't know a polite way of saying this, so I'm just going to say it. The foreskin of Jesus.
Wow. I didn't see that coming at all. I was totally expecting a butt joke. Okay.
No, and this isn't a joke either. I do apologize for any families who are listening to this with their children who now have to have a chat with their children to explain what that is. But basically, there was a serious movement around this particular relic, let's say, of early Christianity, because it would have been the only relic of the body that remained on Earth. And so there were multiple churches that claimed to possess this particular relic around Europe. There are still, I believe, churches, I think in Germany, that claim to house, the Holy Grail, but this is the you know what? I'm going to defer the rest of the discussion on this to a wonderful, wonderful episode of the Constant podcast, which I think I have mentioned to you at least privately.
I'd like to mention that you and I have both been on the Constant.
Yes, that is true. Our voices have been on the Constant podcast.
But I am going to look this up. If there's an episode about it, I am going to look this up.
Yes. There is an episode. We can share the link in our episode description. Firstly, I would highly, highly recommend, if you're a fan of this show, I reckon you would certainly be a fan of The Constant, A History of Getting Things Wrong, which is fantastically written and presented by Mark Chrysler. So Mark did a whole episode on this particular topic. And it's just fascinating to understand the history of it. But yeah, I'm not going to be able to do it justice. I would highly recommend folks go and listen to this episode to understand how people legitimately thought that the rings of Saturn were the holy crucus.
Okie dokie. All right, let's bring it back down to Earth for a second.
Yes.
Uh,
Not where you thought
the
this episode was going, I'm sure.
Do you know anything about the Mount Wilson Observatory Hale telescope, or rather, Hale telescopes?
I think so. I think it was one of like the biggest reflecting telescopes in the world at one point.
It was
It's
once.
at it's at Palomar, right?
There's two. There's the Mount
Okay.
Wilson Observatory, and then that was the 100-inch reflecting telescope. And
Hmm.
then they made the Palomar Observatory, which was the Hale 200-inch telescope. So
Right.
this guy's got two named after him.
That's right. And the Mount Wilson one is the one that's just outside of LA, right?
I believe so.
Very cool.
Yep.
Very, very cool. Yeah. I had the chance to visit the one in LA. I have unfortunately not been to the other one at Palomar.
Well, same thing but bigger.
Right. And here we have another astronomer, George Hale.
George Ellery Hale. Yes.
Very cool.
Very, very
Yes.
good. It was the largest effective optical telescope in the world for a while. And then not. All right, the Paul Wild Observatory.
Oh,
Formerly formerly the
wait. Oh,
this one's
okay.
for
So
you. This one's for
I know
you.
it's. I know. Well, I can't remember the old name. So it's in Narrabri. I don't know what the original name was before it was like just the Narrabri
Cartographers,
Observatory.
the Kul the Kulgura Solar Observatory.
Uh,
Did I say that wrong?
Kalgura?
That's what it says. I don't know much about Australian telescopes or observatories, but I had to throw it in there because everything seemed very U.S. centric.
We appreciate it. Yeah, no. The Paul Wild Observatory is probably one of the telescopes that I've used the most throughout my PhD.
Wow.
So it's the Australia Telescope Compact Array, or ATCA, is located there. Um, Basically, it is a telescope comprised of 6 dishes. So it's a radio telescope. You know, we've been talking a lot about high energy telescopes, and we've spoken a lot about optical telescopes. But this is a radio array of 6 like 20-meter or 22-meter dishes. It's I've not yet been there because
Oh,
it's like 500 kilometers away from Sydney. It's still in the state that Sydney is in. But yeah, super useful telescope that I've used for everything from studying stars in our galaxy to studying supernovae and tidal disruption events in distant galaxies.
wow. Awesome. 500
I love it.
kilometers away. What is that? How many miles? Help me out.
At least 3.
At least 3 miles away. Sweet. That's a big deal.
But yes, named after
I almost
Paul
walked my dog
Wild.
3 miles. I think it's too much.
Paul Wild was a famous radio astronomer who worked for CSIRO, the Commonwealth Scientific and Industrial Research Organization. So it's basically like quite similar to the NSF, the National Science Foundation, but in Australia. And CSIRO is within CSIRO. You have the ATNF, the Australia Telescope National Facility, which owns and operates most of the big radio telescopes here in Australia.
All right. Right on.
Yeah.
The Lick Observatory.
The Shane Lick.
No,
Is it Shane Lick? It's not Shane
No.
Lick.
not Shane.
I thought it was Shane.
James Lick.
Oh,
Is there a Shane Lick Observatory?
There is a Shane telescope at the Lick Observatory.
Really?
So I guess I'm just used to seeing it hyphenated.
Oh, okay.
Um,
So we're both right. Yeah.
yes. There are multiple instruments. Yeah, but okay, yeah, it's going. You've clearly
Yeah.
done more prep on this than I have.
The James Lick Observatory, named after not a scientist, but a philanthropist who really was very big into donating towards the sciences, specifically observational astronomy sciences. And so he helped create or invest in the on top of Mount Hamilton near San Jose, California, the Lick Observatory, not too far from here, just about 30 minutes south of me.
Cool.
Yeah. Next, the
That's very cool.
Lowell Observatory.
Yes. This one, I think came up in our previous episode with Danny when we were talking about
Yep.
Martian canals, right? So,
Yes.
as far as I know, okay, so Lowell also wasn't an astronomer, right? Well, he
He
became an
was
astronomer,
an
but he wasn't.
astronomer. He became an astronomer. He was a businessman first and then
Right,
worked his way up.
right. Um, you worked his way up to it. Um,
Astronomer.
I think, like he was brilliant, and the money and time that he invested is still paying dividends today. Like the Lowell telescope is a brilliant piece of technology. Um, and I think like the fact that it was designed specifically to be in what's it, Flagstaff,
Yep.
uh, in Arizona, was like a really cool decision that I don't think people were actively deciding to build stuff on, like, dry, cloudless, rainless areas high up before him.
Yeah.
Um, but I feel like he was like historically wrong about a lot of things.
He
Like
was.
that's the way that science goes, right?
Yeah. You never know until you test it. Until then, you have nothing to test. Makes sense.
Yeah.
Fun fact about the Lowell Observatory:
Yes.
a handsome gentleman by the name of Clyde Tombaugh used the
Oh
Lowell
yeah.
Observatory to discover the
A dwarf
ninth
planet.
planet, Pluto. That's a
Yes. I
hill.
think
I'm
that
willing to die on that hill. Not a lot. That one, for sure. It's a planet. Sorry, it's a planet.
that's fine. Was it? Oh, now I'm definitely getting my wires crossed on this. Like I can't remember if it was maybe it was the Lick one of the Lick telescopes. But um, there was a telescope that was shot with a bullet. Yeah, I think yeah, it wasn't the for a second I thought it was Lowell, but I remember reading that there is a telescope that got shot with it. No, it wasn't either of them. It was a telescope in Texas. Um so Lick isn't in Texas, right? And Lowell's in Arizona. Maybe it was a McDonald telescope, but famously, it's a telescope that has like a dozen or half a dozen bullet holes in it from some incident,
I
and
got
it's
it.
still operating.
I
What's
made a
that?
note to myself to look that up. That sounds awesome.
My money would be on the yeah. I think it's a telescope at the McDonald Observatory, but it's definitely a telescope in in Texas.
Okey-dokey. Well, so not Liquor or Lowell because those are here.
Yes. Yeah,
I'm
they're
not.
not
I'm
low.
no. And by here, I'm where I am, which is nowhere near Texas. Even with Texas's gargantuan size, I am still very far
Huge.
away.
Yeah.
All right, the Keck Observatory.
Yes. Keck Observatory in Hawaii.
Mm-hmm. Which is the best place to build an observatory. or a shoe store or a gas station or anything really, because it's in Hawaii. Or just don't. It's a great place to not build anything. It's
Also,
Hawaii.
yeah. I mean, yeah, there are also some issues with that mountain being used for telescope building because of some indigenous rituals and associations that they have with that mountaintop. I know that there are some agreements with like the what is it? It's Manukia, right? The mountain.
Yes.
Yeah. So I
Yeah. Mauna Kea or Menikia. I think
yeah.
it's Mauna Kea.
Keck himself, I know nothing about. I don't
Not
think
a
he was an astronomer.
scientist. Um, he founded the W.M. Keck Foundation, which founded the construction of the Keck Observatory.
Okay.
Um, and he supported scientific research and in chemistry, astronomy, medicine. Big proponent of putting his money into research and advancement of knowledge. So good him. Sorry about
Yeah,
the
nice.
Mauna Kea controversy. All right. Let's, the Vera C. Rubin Observatory. Brand new.
Yes.
Brand new.
This, yeah. I think we hinted to this in the episode with Danny.
Man, way
Um,
to go, Danny.
seriously. We also we discussed on a related note just earlier this episode Kepler and Kepler's laws.
Mm-hmm.
Um, so what Vera Rubin was well, what she should have potentially won a Nobel Prize for was the fact that she found, by using Kepler's laws, she found the first evidence for dark matter. Um, so I think Fritz Zwicky normally gets the credit for discovering dark matter, even though I don't think that he had any direct evidence for it. I think it might have been more theoretical work, but I might also be mistaken. Um, but what Vera Rubin did was basically study the velocity curves of galaxies. So, what does that mean? It means that when you look at different parts of a galaxy from the like you take a spiral galaxy, and you look at the middle, and then you look a little bit away from the middle, and you kind of go out in radius towards the edges, and you measure how fast that material is rotating, right? And we can do this with spectroscopy. We can look at like the redshift and blue shift of how part of the galaxy is shifted, that light is blue shifted towards us or red shifted away from us. The amount of that shift tells us how fast it's moving relative to us. And so what she was able to do was to see that the stuff in a galaxy, the stuff we can see, which is made up of stars, normal light stars and gas and whatever, does not follow Kepler's laws. They're
Ooh.
basically finding evidence for additional dark matter. So you should basically see that as you get out further towards the edges of the galaxy, the velocity curve declines. Basically, the velocity of the stuff orbiting at greater distances from the middle of the spiral galaxy should be lower, just according to Kepler's laws and looking at how much stuff we see there. But what we actually see when we make these measurements, what Vera Rubin saw, was that the curves kind of flatten out. And that showed that there was evidence for a dark matter halo, basically an area outside of where the visible material of a galaxy ends. There is still stuff there. It's just dark matter stuff that we can't see. So yeah, Vera Rubin, incredible human being, had to deal with a lot of sexism in her life. I think she had tried to get into Princeton and was not able to get into Princeton because she was a woman. She was just, a brilliant human being. I think her husband was also a physicist, and she managed to, do a brilliant job raising 4 kids and also be this incredible scientist.
Dang.
So, yeah, hats off to her. And I think the Vera Rubin Observatory, Vera Cooper, which is her maiden name, Observatory, is going to be producing phenomenal science over the next decade. So definitely watch this space.
Oh yeah, impossible amounts of data are just going to come screaming in from this thing.
Yeah, 20 terabytes per night.
Yep.
Oh, geez.
I've been seeing a lot lately. Today is August 21st. We are within a couple of days of some anniversary of a 5 megabyte computer being delivered to NASA on a huge pallet and being loaded into a room. and and now we're having 20 terabytes a night.
Well, I don't know if I told you, but ASCAP, the Australian SKA Pathfinder that I use a lot, has a raw data rate of 12.5 terabytes per second.
It's phenomenal.
We can't even deal with it. We cannot save that amount of data.
So data's coming in and just being lost.
So it's we could probably do a whole episode on this. But basically, what it's done is data comes in and it gets averaged into like 10-second chunks. So you're like losing time resolution in order to reduce data volume. And then you might be thinking, well, hey, like, what might we be missing? Things that change in the sky on scales shorter than 10 seconds. And I'm glad that you asked that. Because there is a really, really cool system called Krakow that was designed to basically work with the raw voltages. So raw voltage data comes in, about 12.5 terabytes per second. They buffer that data. They run a search algorithm on it, looking for fast radio bursts, FRBs, and other weird things like that. Short timescale stuff changing. If they find something, the data gets saved. If they don't find anything, then the data gets averaged. And lossy compression, as data scientists might call it.
Huh.
Yeah.
Huh. Okay.
Yeah. We could. I probably am not the right person to explain like the depth of technological brilliance that's involved in this ring buffer system. But yeah, there are folks who work on it directly, like Keith Bannister or Ziteng Wang, Andy Wang, both really, really awesome radio astronomers who work here in Australia who developed this.
So our technology
Super
is
cool.
now too good. All right, one more. Let's wrap this
Okay,
up.
last one.
Last one, and this is a favorite of mine. It's a sad one.
Oh no.
And I did not know it had this name, the Arecibo William E. Gordon Telescope. I had no idea the name William E. Gordon was associated with the Arecibo Telescope.
Neither did I.
Yeah.
I know about Arecibo,
Mm-hmm.
and we're all very sad that it doesn't exist anymore.
It was terrible. Anyway, it was named after William E. Gordon. He's a physicist and an electrical engineer, not an astronomer, but he was the guy who conceived of and designed the Arecibo telescope itself. And Arecibo telescope, do you know where the name Arecibo comes from?
I feel like I knew this once. It's in Arecibo. Like that's the name of the place, right, in Puerto Rico.
It's the name of the municipality in Puerto Rico where the observatory was built. But
So is that?
Yeah, but the name Arecibo itself.
What does it mean?
is the name of a chief who ruled the Taino Cacique, whatever. I think that's the name of the people in that area before the Spanish colonial period came, and that area still keeps the name after that chief, Arecibo.
And that chief was an astronomer, right?
Sure. Yes. I'm sure actually, I bet he probably was, because the night sky back then was just phenomenal.
There you go.
No city lights,
Wow.
no pollution, just
Nope.
stars.
That's how I feel. Good old stars.
Good old stars.
This
Well,
was
this was
fun.
fun. I like this one.
I do. Yes. It was so nice also just like having an episode where you and I get to chit chat
Just
and
chit, say hey.
hello. Yes.
Give you
I
my
hope our
appreciation for your Cosby sweater. Very nice.
thank you. It's very fluffy. For people
Yay.
just listening, I'm wearing a very fluffy, bluish, reddish, whitish sweater or jumper, as we say down here in Australia.
Jumper. Call your
Jumper.
sweaters jumpers.
Yep. Don't Benjamin's just like looking off into space, trying to understand what reasonable link.
I'm trying to cook up some etymology for the calling a sweater a jumper. I can't.
I don't know. Like Australians have
Sweater
weird
I
names
get,
for things.
because you sweat these things because they're hot. But even then, it's not even the best name either. I like the fluffy outer layer. I like that much better.
Yeah, it would be a fruitless exercise to try to understand where some Australianisms come from. Like there are things like sunnies, which are what we call sunglasses. Like that makes sense. You know, trackies, which are tracksuit pants. That makes sense. But jumper, I couldn't tell you. I'm not allowed to.
Allowed to.
It's a state secret.
I'm not allowed to tell you.
Unfortunately.
All right. Enough.
It's,
All right, that's it. I'm done. Stop it. We're out.
this was fun. Thank you, Benjamin, as always, for doing incredible research on this episode and for sharing your knowledge. Thank you to all of our listeners as well, and our watchers if you're getting to see our beautiful faces. Benjamin, where can the good people find us and our episodes?
Absolutely. You can find us on TikTok or YouTube if you want to watch our show. You can listen to us pretty much anywhere you listen to your podcasts.
Oh yeah,
it's everywhere. If you want the audio only version, and you can find me under the name Science Actually pretty much anywhere. Facebook's the big one if you want your daily science facts or your daily collective nouns. Murder of crows, squad of squid. I have so much fun doing those things. That's where you can find me as their name Science Actually. How about you, Kovi?
Folks can find me at Fun Fact Science on all the socials, and you can check out our episodes on YouTube if you want to see our faces, or on the TikTok. Anywhere, just search for Science Actually presents The Nerd and the Scientist, and we will see you. Or at least you will see us and hear us on the next episode.
Exactly. It's a one-way thing. We hope you enjoy us. We can't enjoy you, but you can enjoy us. But we appreciate you, which is something else.
Absolutely.
All right, everybody. Thank you for listening.